memorize this symbol instead. The marker is the position. This symbol is the variable, the first variable. I memorize this into W, but don't go right to write it. Keep it. Then go left, right, write it. You do the loop as before. You copy everything else. Right? When you're done copying everything else, go to your marker. Right? And write whatever W was, whatever you memorized. This will have disappeared now. B will come here, A will come here, right? But this, it will be W. At the last step, go to your marker and replace it with a W, you're done. You're sitting there in that position. So what's the modified algorithm? We said the first step should be write a marker in the current position. You don't want to lose that position. So write a 1 when you start. Okay, I wrote a 1. What? Go left. Memorize that letter because this will be the last one you will shift. So go left. If you see an A or a B, memorize into whatever W. Okay. And now what? I'm here. Go left. Go left. If you see an A or a B, memorize it into T. Then go right and copy it. Now you start the loop you had before. So go left. If you see an A or a B, memorize it into T. And right. Do what? Right it there, right T. Then what? Left. And then left again. Which left do you come to? This one. To this left. Of course, if you see A or B. Because if you see a blank, when you go left, you see an A and B. I'm sorry, that's fine. Yeah. You see a B, you go left. Instead of seeing A and B here, what if you see a blank, as you had before? Well, if I see a blank, what does it mean?
Move right.
Go right and write a blank. Wait, is that right?
Yeah.
I don't know, I just copied blindly from before, my brain is tired. Okay. Where were we here?
We are placing blank space on this.
What we did here? I memorized this into W. Right? I went left.
B to right.
I memorized it. I copied it.
A to right.
Right? I go left. That's the one I just copied. Right? Okay. I go left. That's the one I want to copy. Okay. So you go ahead and you memorize it. You go right and you copy it. You copy it. You go left. That's the one you just copied. You go left. Well, that's a blank. Yes, that's correct. If you see a blank, this means you're done. You go right, you write a blank. You already copied that. No. Why we can prove it using a computer? Is this convex free? No. Why? Okay. So the next question is, can you build a Turing? Is this Turing decidable? Can you build a Turing machine to decide if a string belongs to there or not? The answer is yes. Okay. Let's build a Turing machine to decide this. So how should this machine work? If you start, $sign is the start of the day. If you start with a string on the day and the pointer being there, is there a Turing machine that will process the string and substitute it with yes if he belongs to the language? No, otherwise. So let's build such a Turing machine. I know there is a Turing machine because I can write a program for it. Right? It's like a freshman exercise. Okay? And Church's thesis says what? Anybody knows? He says Turing machines and algorithms are equivalent. Yeah. Therefore, programs. Yeah. The only things you can program are the things you have algorithms for, which are equivalent to Turing machines. So this is Turing decidable, right? This language, if I can build a machine to say yes or no for a given string. There are some problems that are not Turing decidable. So not everything can be solved. That's why this is important, right? If there is a problem for which you cannot find a Turing machine and you can prove that, this means you cannot solve it algorithmically. Okay, pseudo language. What's your algorithm? What will we do? Remember the library? You can use any of the library functions, including the shift left or shift right. Okay, what should I do? Well, I want A's, B's, and C's equal, right? Go once right. What if that's a B? It's not good because I don't have an A, too much, or a C. Okay, I go right. If it's an A, there's potential for this string. If it was B or C, I should go all the way there, come back, erase. When I get to the dollar sign, go to the right no, I'm done, it's not. Okay? But if it's an A, what should I do? You can keep a point, a marker there to know where it is, and then go skip the rest of the A's, go to the B. If you never find a B, if you find a C, do the no, okay? But if you find a B, right, you put a marker there, go find a C. If you find a C, go back to the first marker, and go to the second marker, to the going left. Right. I can work with markers, okay? But I have the shift left function. That would be another way to avoid keeping a marker. So why don't I do it this way? I go, I find an A, shift left. I cancel it. Okay. Skip the A's. So let's start. I go once to the right. This is the library machine, go once to the right. Okay. We said if you go once to the right, if you see a B or a C, you know the answer is no. So do the if statement, B or C, and the answer is no. So I should go all the way to the right to find the blank. How do I have to replace this whole thing with N, or something that means no. Okay. So go to the right until you find a blank. Go left. If you see an A or a B or a C, replace it with blank. You don't want to replace dollar with blank, otherwise. Okay? So if you see an A or a B or a C, replace it with blank. Right blank. So I go to the left. C, right a blank. Then what do I want to do? Loop. Left. C, right a blank. Okay? Left, right a blank. Eventually, I'm here, I go left. It's an A, write a blank. Okay. I go left. If I see a dollar, if I don't see A, B, or C, right? That's how you exit the loop. Every loop must have an exit clause. So if you see a dollar, right? What do you do?
Go right.
Go right. Right like N. That special symbol. And go left, and you will have this on the table. You'll be there and you'll have no. Okay, if that's not the case, you go to the right. If you see an A. What should you do, you say? I want to mark it off, you know, but instead of marking, I shift left. I shift left, everything moves. Let's just do this. Okay, these guys are here. Okay. That was very good. If you see an A, what? No, because shift left. What did I do?
Oh, okay, just
Starting this
move
was removed.
Okay.
I don't need to replace it. I cancelled it.
Okay.
I can't do this now.
So now you have to find a B.
So now I have this on the table. I shifted left here.
Okay.
Right? So now you have to find a B. Okay. Well, what are the cases when you shift left? If you see an A, you want to skip it. So let's do this. If I see an A, what do? I go right. If I see an A, I go right. You see, you said I have to go to find a B, so I could attempt to go right until you see a B. But what if you don't have a B? That will be an infinite loop. I introduced an infinite loop in my program. Suppose it was A, C, C, blank. Go to the right until you see a B. C, no B, no B, blank, no B, no B, no B. Blanks are infinite. And I assume that the tape is infinite. So if the tape is semi-infinite, I will never stop. So I cannot do this. Okay. So if I have an A, I go to the right. If I have an A again, what do?
Go right blanks.
Go right.
Keep going right.
You don't write blanks. You don't want to cancel them.
Keep going.
Okay, so if I have an A, I do a loop. Go right, go right, go right. Okay. Since my string is finite, I will not have the infinite number of people. Eventually, I will stop having A's. It's a finite string. There is no danger here. Okay, so A, then eventually you will see a B, a C, or a blank. You know, what else can you see? Okay. So what if I see? Yeah, let's go here. So I'm going right with A's. Here, you shifted left. What if you see a B? You cancel the A, right? Okay. If you see an A, you will keep going. But what if you don't see an A? What if you see a B?
You can
Shift left to cancel the B. Right? Because there is a match here. I cancel one A, I have to cancel one B. So if you see a B here, shift left. What if you don't see an A? When you see an A, you shift left. What if you see a C? Rejected. Okay, so I better go and do this business here. You want to go over here? I don't know how to bring it around there. Here. You know what?
Can you do like that?
Go like this.
Across. Oh, that way.
Okay. Right? Now, but if you see an A, you go right. A, go right. What if you see a B eventually when you run out of A's? Go there, shift left. You cancel the first B you see. But what else can happen here? A, go right, go right, go right. Instead of B, you see a C. Where do you go? No, it's not good. Let's just do this. What if you see, forget the case here, you could see blank. See an A, you shift left. What if you see a blank? The same as C, rejected.
Yeah.
So you see C or blank here. C or blank here. That's no. Okay, if it is not no, if you show a B, you will shift left, you cancel it. Now, what if you see a C? Shift left. Okay, what else can you see? If you see another B, you have to repeat this
Yeah,
loop here.
same thing.
Skip the B's. You're looking for a C now. So if you see a B, go right. A B, go right. Keep going right. Eventually, if you see a C, go to the shift left. But what can happen is, what if you see an A? Well, that's no good because this means you have A's following B's. You just shifted the B and then you see an A. What if you see a blank? Well, you don't have a C to match off. This means the A's, B's, and C's don't match. So you go to the no. Now here, you're shifting the B's, you never see a C, but you see a blank, it's a no. Or if you see an A, it's a no. Right? Because you have A's after the B's. Okay. So keep doing that. Eventually, if you show a C, you shifted it. So now you have one cycle match. A, B, C, shift, 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 3 shifts. Okay, now what should you do after you cancel the last C?
Yeah.
You cannot go here. You have to go back to the start of the tape. Start all over. So first, how do you go back to the start of the tape?
Look for dollar.
Right. You go left
Okay.
until you find dollar. And this will not be an infinite loop because first of all the tape is finite, and you will not hang because you always assume there is a marker there always, the start of the tape. So you go to the left of the tape, and you start all over. So I'll bring it back. Now, if the things match, what will happen? What are we missing here? We're never saying yes. we say a lot of no's, but what will happen? Right? We're missing something. Where is the yes case? Yes, it's accepted. Well, look here. If we see an A, if we see a B or C, we do stuff.
You see a blank.
Yeah, right. If we see a blank when you start over, this means everything cancelled. That's the yes case. So from here, if you see a blank, this means on the tape you have this left, right? So if you see a blank, what should you do? Where are you? Here, you just saw the blank. You should write yes. Write yes.
Yes.
And go left, and you're done, and you have dollar yes. So you have the regular, the convex 3. These are proper subsets of each other, right? You can always, you can find a language here that does not belong there. And you can find a language here that does not belong there. A question that remains is, are there languages outside this set of Turing decidable? Are there languages that are not Turing decidable?
Yes.
The answer is yes. We'll see later. Right. Suppose you have a function from some alphabet star to sigma 2 star. some other alphabets start. We say it's Turing computable if you can build a Turing machine that works as follows. If you start the tape with a string in the first alphabet, okay, when the Turing machine is done, what's left on the tape is the image of that string under the function f. Okay. This means you can write a function for this program, right? These are so any non-Boolean function. Some functions are computable, some are not. Let's do an example. All right, is this function Turing computable? Give it a string, it will double the string. So this is a function from sigma star to sigma star, and let's say the alphabet is ABs. You have an alphabet, you have a function from sigma star to sigma star. Now the question is, where does the tape start? That's a variable. Like if you're doing a Turing machine X, this notation means Y is another Turing machine. This means if you see that symbol, you memorize it in a variable W, and then you go and do Turing machine 1. Until you see a blank like I have here. A symbol, like A and B in the alphabet, I memorize it in a variable. Now, my plan is to go to the first blank then, go to the second blank, because at any given point I might have partial copy here. So the new letter I want to copy here. So I go to the first blank, I go to the second blank, which right now is right after it, and I write what I memorized. So I will write an A. So I'll have this. But now I have to go left, I need to know what I just processed. Right? So I have to use a marker now. Shift won't work because I don't want to cancel my string. Okay. So I'll put a marker first. I'll go to the second blank and I write the memorized one. Go left up to the marker. I write back again what you memorized. That in WA, write it back there. Repeat, which means go to the right. Memorize it into W. Put a marker. Go to the second blank. Write W. Go back to the market, write W. That's it.
Can you memorize just one character or more than one?
One character.
One character at a time using our notation. I mean, you can do it twice in a row to memorize two. Go to the right. If you see an A or a B, memorize it. Let's go with the variable W. Say uppercase means variables, lowercase is symbols. Okay. Go to the right. If you see A or B, memorize W. Put a marker here. Let's say our marker is the symbol 1. Write a 1. Go to the right until you see a blank. Go to the right until you see a blank again. You want to put the second blank. Okay, now you're here. Write W. Then copy it. So here I write A. Write W. Now what?
marker
left until
on.
you see the marker. Okay. Left subscript 1. Left until you see the marker 1. Then what?
Right.
A W, right. So you put the 8 back there. Write the W. Okay. And then you repeat.
Yeah.
Repeat not here, here.
Here.
You go to the right from the current position. So you come here. Okay. You go to the right. You see an A or a B, you memorize it, you go to the second blank, right blank, right blank. You put a marker, I forgot to say. Right? You go to the second blank, you copy it, you write W. Go to the left until you see the marker, write W. Come back, you go to the right. Now let's do something else. Okay, so we have a Turing machine. Let's call this machine C. C for copy. He copies something. The whole string. He duplicates. But the problem is there is a blank in the middle. So just double. AB will become AB, AB. No blank in the middle. So when I start the tape with when the machine is done, so it will have